Hello dear students, let us start the next lecture. In this lecture, we will quickly understand the definition of the triple integrals. So let us start. Although first consider a finite region D in the XYZ space and suppose f is a continuous function on the domain D. This is the XYZ space and this is the region D, which is a solid region. And since we are supposing that this is a finite region, so it means that this region D can be enclosed in some sufficiently large cube as shown in this figure. Now we will divide this region D into its elements, which are rectangular boxes, and for this we will use the planes which are parallel to the coordinate planes. So although first we will consider the planes parallel to the XZ plane, and these are shown in this animation. And then we will consider the planes which are parallel to the YZ plane, and these are shown here. And finally come the planes that are parallel to the XY plane, and these are also shown here. All of these planes are dividing together this domain D into rectangular boxes, which are the elements of this domain, and we will suppose that there are total n elements that lie inside this domain, okay, and we are considering only the elements that completely lie inside this domain. Now I will remove some of the planes and I will keep only the adjacent planes parallel to the coordinate planes, and these adjacent planes are dividing this domain into one element, which is shown here, and this is a rectangular box, okay, and I will call it the ith element, and I will be the summation index that we will use next. Divide D into n rectangular boxes by using planes parallel to the coordinate planes. One of the boxes is shown in this figure, and the volume of this box is dvi, that is equal to dxi times dyi times dzi, okay, and I will zoom this rectangular box here, and the lengths of edges of this rectangular box are dxi, dyi and dzi. dxi is the length of the edge parallel to the x-axis, and dyi is parallel to the y-axis, and dzi is parallel to the z-axis. Okay, now we will consider the Riemann sum to define the triple integral of f over the domain D, and this Riemann sum is the summation over the summation index I equal to 1 to n, and this summation is applied on f of xi, yi, zi times dvi. Here the point xi, yi, zi is a point of this element. Okay, now note that this Riemann sum is the same as for the case of double integrals and the single or definite integral. Now in order to convert this Riemann sum into the triple integral, we have to take the limit on this summation as n approaches to infinity. And under this limit process, this summation becomes the triple integral of f over the domain D. And in the integrand, the summation index I disappears or drops. And we will also consider the expression for the total volume of this solid region. Okay, the triple integral of f over the domain D is then defined as the limit of the Riemann sum as n approaches to infinity. So take the limit n approaches to infinity on the Riemann sum. You get the triple integral over the domain D of f. Okay, and note that the subscript I, which is the summation index, is removed under this limit process, and the summation is converted into the triple integral of f over the domain D. Hopefully this was clear to you. Now the total volume of the region D is obtained by setting f equal to 1 in the triple integral of f over the domain D. Hence, the volume V of the region D is given by the triple integral this one. Hopefully this was clear to you. And furthermore, note that the volume of the ith element was dvi, that was equal to dxi times dyi times dzi. Now, in order to obtain the total volume V, we have to take the limit as n approaches to infinity on the summation from I equal to 1 to n of the volume element dvi. Okay, and under this limit process we know that this summation becomes the triple integral over the domain D, and in dvi the summation index I drops, and if the summation index I drops on the left hand side, it also drops on the right hand side. Okay, therefore the integrand is only dv, okay, or dx times dy times dz. Hence the total volume V is equal to this triple integral over the domain D. Hopefully this was clear to you. And furthermore, if F defines the density function of the solid region D, then this triple integral becomes the total mass of the solid region D, as we will see in the upcoming lectures. This completes our today's discussion. Thanks for watching.